Hi guys, how you going? Want to today look at the concept of the normal distribution. Now we've heard of the term of a mean value. So the mean value is this central value here, and either side of the mean value we have what we call a standard deviation for your data. And there is a formula obviously to work out what the standard deviation is. We'll talk about that later. But let's say we've been given our standard deviation. So what we know is with a normal distribution that 68 roughly % of our population lies within one standard deviation. All right. So if you start looking at that data there, and then we know that within two standard deviations, 95.44% of our population lies within two standard deviations, and within three standard deviations, nearly all of our population lies within three standard deviations. Now obviously if you've got a value say out here, we would classify that as an outlier, and that would be outside three standard deviations in a little bit. Alright, so that sort of hopefully matches up with what you've learnt in the past with that. So we certainly are going to base a lot of our information on the normal distribution. Now just want to show a little clip here that goes through the idea of a normal distribution. Alright. So obviously what we're doing here is we're measuring cockle shells. Alright, so we're just taking a tally of those things. Now what this video is showing you is if you take a large enough sample, and you'll start seeing the graph down the bottom, if your sample is large enough, doesn't matter what your sample is, it will always become a normal distribution. Now generally a sample of 30 or more will always be normally distributed. Alright, so you get that sort of bell-shaped curve. So that's what that little demo is all about in terms of showing you. Now, we're not going to do these questions, but if I talk to you about that, you could look at your graph. You could say, in terms of this example here, if you had your mean at 50 and the standard deviation at 6, so if I was looking at 6 either side of 50, that would be 44 to 56. We could use that bell-shaped curve to work out that we'd have a 68% chance of picking someone that would actually lie inside that particular value. Alright, so that's what that sort of represents. And again, if I went for 38, well that would be over here to be the two standard deviations over there. And so therefore you could go from 38 through to 64. So that would be 95.44% of our population would lie within the two standard deviations. So that sort of lies outside of our particular realms of what we have to do. What you'll generally find is the population stuff that we'll be looking at won't necessarily lie on these lines. It will actually lie somewhere between these lines, okay? So that's what we'll be doing when we start doing our normal distribution information. Now, in your book, you'll see something which is called a Z-score. All right, a Z-score. So what is a Z-score? Well, a Z-score is in fact your variable X, take away your mean value, your population mean, over S. Okay, so that is the formula. So if I was looking for something which had some variables, I could use a variable. So let's say we have a mean of 50. Like we did in this example here, standard deviation is 6. Okay, so if I want to work out my Z-score from when X is equal to 50, what am I going to get? Okay, so if X is equal to 50, that means that it's going to be 50, take 50 all over 6, that's going to give me an answer of 0. Alright, if I look at a value of say X is equal to 44, okay, 44, take 50 all over 6. Okay, that's going to give me negative 6 on 6, which is equal to negative 1. Alright, do one more example over here. Let's say we had X is equal to 56. Then that's going to be 56 take 50 all over 6. So that's going to be 6 over 6, which is 1. Now, the idea of the Z-score, you'll find there's a whole table of these values. And what they relate to is your standard deviation. Okay, so a Z-score of 1 is one standard deviation away from your mean. Right, so we know if we're at our mean value, which is there, that's got a Z-score of 0. Alright, and then we've got Z-score over here, -1, have -2, we'll have a z-score of -3, and then it goes 1, 2, 3. So that's sort of relating how many standard deviations you are away from your mean value. Now, the reason why we've traditionally done that is in your book there's a whole couple of pages of tables, and I think I could probably show you those. So if we scroll down through here, you'll find these tables. Now, the good thing about having a graphics calculator is we don't need to worry about looking at these tables anymore. All right, so the tables basically can be got away with because we have, this is what I'm looking at here. So these tables are looking at the z-score. So for that you can actually work out the area bound by a lower value and an upper value. All right, so that's what we don't have to do, all right, based on the fact that we do have a calculator now that does the work for us. So let's have a look at the sort of questions that you might have to do. And these aren't from your textbook, these are from the Math Apps textbook, but same sort of questions. Alright, you've got two things on your calculator, and I'll show you these, but I'm just going to write these down for you first of all. So if I wanted to do this first question, now when I start looking at the binomial, like it's not a binomial, it's a normal distribution, there's two types of normal ones that you're going to be looking at. So you got a normal, you got a PDF, alright, and then what you do is you have your value, and then you have your mean value, and then you have your standard deviation. Okay, and then what that does, that is actually working out the probability of a result. Right, so if you want to know if you're rolling a dice or something like that, the probability of getting, X number of sixes, then you could use that value. Or, if you had a distribution and a sample and you wanted to know the number of people that were exactly 170 centimeters tall, this is what you would do for that one there. Now, if you're looking for a range of values, unlike the binomial probability, the CDF here, you have your lower value, then you have your upper value, then you have your mean, and then you have your sample standard deviation. Now, if we don't have a lower value, what we generally use is minus e to the 99. And if we don't have an upper value, we generally use e to the 99. All right, so I'll show you how that looks on the calculator. So let's look at an example. We'll do the first one. All right, so the mean length of nails is 25.3 millimeters, standard deviation of 0.4 mils. What percentage of them would you expect to be greater than 25? Alright, so if we know, and it's probably sometimes a good way of actually writing these things down, x bar is in fact 25.3, our standard deviation is in fact 0.4. So the setting out that you need to show is in fact the following. So probability that x is in fact greater than 25 millimeters. Alright, so that's going to be equal to the normal CDF, okay, put our lower value down there, which is 25. We don't have an upper value, so we'll use e to the 99. Our mean is in fact 25.3. Our standard deviation is 0.4. So this is where we go to our calculator. Alright, so let's have a look at that. So what we have to do is go to our distribution, so second function distribution, and we come down to number 2, which is the normal CDF. Right, so then we're going to put in our value. So our lower value is 25. We use our comma. Our upper value is going to be E. So our E button is the one with the comma, 99. Our mean value is 25.3. And our standard deviation is 0.4. So when you do that, we'll give you a value, and it's giving us an approximation of 0.34. So when I go to this, now it's not an exact answer. So when we do this, we always write the four significant figures, 0.7734. Now that equates to, you've got a 77.34% chance that a nail would be in fact greater than 25.3. All right, let's do the other part. So what would be the chances of me getting a nail between 25 and 26 millimeters? All right, so that one there, I'd say probability that x is greater than 25 and x is less than 26, right? So that would be equal to the normal CDF, right? Put our lower value 25, our upper value 26, that still should stay the same, and 0.4, and so therefore when we go, we're going to get an approximate answer again, go to our calculator. Now the quickest way to do this is probably to go second function enter, right, because you've already got those values in there, and all I have to do is change that one now to 26, and just delete that value there. Everything else is the same, and it gives me a value of 0.7333. Alright, so let's go to that, so 0.7333. So that means I've got a 73.33% chance that a nail lies between a length of 25 and 26 mils. Let's look at this one here. The probability that x is in fact less than 25 millimeters. Alright, so again, we're going to use the normal CDF, so that would be the normal CDF. Now, no lower value, so what we're going to use is minus e to the 99, and then we're going to go upper value is 25, our standard deviation is the same, our mean's the same, our standard deviation is the same as well. So go back to your calculator. Now, we could go second function enter, but remember, I'll show you what to do. So distribution button number 2, right? Okay, so it's a CDF. Our lower limit is what? It's going to be minus e to the 99. Our upper limit's 25. Our mean value is 25.3. Our standard deviation is in fact going to be 0.4, and then we go enter, and that gives us 22.66. Okay, so go back to that. That's approximately equal to 0.2266, which is 22.66%. Now notice, obviously this value over here was 77.34. If you add these two values together, you get pretty well 100, don't you? All right, so you know if it's not greater than, it's got to be less than, doesn't it? All right, so if we're looking at that particular value, then that's what we're doing. Just show you the other one. What would be the probability that x is in fact equal to 25? Okay, so then if we had a particular value we had to be equal to, that's when we're going to use our normal PDF. Okay, so that's looking for a specific value, so that'll be 25, put in our mean value 25.3, a standard deviation of 0.4, so go back to our calculator, go to the distribution, so this one is number 1, right, so put our value of 25, mean value 25.3, a standard deviation of 0.4, enter. So we've got a 75% chance, 75.28% chance of actually getting a nail which is in fact that length. Alright, so approximately equal to 0.7528 I think it was. Yeah, 28. Alright, so 28. So therefore we've got about a 75.28% chance of getting a nail, which is in fact 25 millimeters long. Alright, so I hope this helps you working your way through those particular questions to do with the normal distribution. Now, I will post another video very shortly about the second part of that, because we have to look at the inverse norm, and then we also have to look at how you might use the z-score in terms of working backwards in a question. Alright, if you're given some information, you have to work backwards. So I'll do an example of those for you as well. So good luck with those questions. Have a look on the overview sheet for the ones that you have to do. The normal distribution stuff is pretty easy, and I know you did it last year, so you shouldn't have too many problems with it. But if you do, make sure you catch me in class.